Hello everyone. This video will give you an overview of the main topics that you should study in preparation for your mastery quizzes covering standard G.2, G.3, and G.4. All of these standards cover the topic of transformations, which simply means a change in the size, position, or orientation of an object. We are not going to talk about changing the size of the object. We are focusing on rigid transformations, which means the objects stay congruent to the original pre-image. We will break these quizzes up into smaller quizzes covering specific standards. One quiz will require you to recognize the difference between a reflection, a rotation, and a translation. Simply said, a reflection is when an object flips over a line of reflection. A rotation is when an object turns around a point of rotation, and a translation is when an object slides to a new position on your coordinate plane. When naming your pre-image and image, you will use all capital letters to represent the vertices of the object. Your pre-image will have letters like A, B, and C, and your image will have letters like A prime, B prime, C prime. The word prime is used when you see an apostrophe in this situation. One of the quizzes will focus on your ability to graph the image in a coordinate plane of a reflection, a rotation, and a translation. If you are trying to complete a reflection, you will see a line of reflection. It can be on the x-axis, the y-axis. It could be a vertical or horizontal line not on the axis, or you can see a diagonal line as well. This is a simple type of reflection, but all reflections will be the same. We want to make sure that the pre-image and the image are on opposite sides of the line of reflection and the same distance away. So we can simply count from the point to the line of reflection and then count that same amount in the opposite direction. So point E is 1, 2, 3, 4 points away from the line of reflection. So E prime needs to also be 1, 2, 3, 4 points away from the line of reflection. Point D is 8 points away from your line of reflection, so D prime will also need to be 8 points away from your line of reflection. And point F is 9 points away from your line of reflection. F prime will also need to be 9 points away from your line of reflection. Before you submit any answer, make sure you check to be sure that the shapes are the same and the same size. Reflections should look like mirror images of each other. If you are asked to complete a translation, you will be moving all points from the shape to another spot in your coordinate plane according to a specific rule, which they will tell you in the directions. This one asks you to move all of the points to the right 9 units, so we're going to do exactly that. Take point S and move it over 9 units. There's no line of reflection here, so you don't need to count to a line and then from a line. Just move each point 9 units. S prime will end up at the ordered pair 3, 6. We'll move R as well. R prime will end up at the ordered pair 7, 6. Q prime will move 9 points over as well. That will end up at the ordered pair 7, 2. And then point P will move over 9 points as well. P prime will be located at the ordered pair 3, 2. Finally, you will be asked to rotate an image. In doing so, you do need to follow your rules. You can find this in your Unit 1 resource, along with videos to help you if you're still struggling with this topic. So you will either rotate your image clockwise or counterclockwise. Think of literally the hands on a clock and rotate in one of those two directions. And then depending upon your degree of rotation, which will either be 90, 180, 270, or 360, you will follow the following rules. Either keep your variables where they belong and change the signs, or swap your variables and potentially change the signs depending upon which degree of rotation you have. The example that I'm going to show you has a counterclockwise rotation of 270 degrees. So we're going to focus here on this rule, and I recommend that you either have pen and paper with you to write down the new ordered pairs, or you write on your computer screen. First thing I would recommend that you do is write the rule up at the top of your screen. So I have a rule of y negative x for this 270 degree counterclockwise rotation. So I'm going to go ahead and take my shape and rotate it counterclockwise, which would be going the way that you see my mouse going right now. 270 degrees means 3 quadrants over. So I should see my final shape end up over here in quadrant 3. What I would recommend that you do is go ahead and write down all of your original or your pre-image ordered pairs first. Point A is located at the ordered pair 4, -9. Remember, when you're writing points, the first number is the X number, which goes left and right. The second number is the Y number, which goes up and down. We always place a comma in between and wrap parentheses around it. Point B is located at the ordered pair 10, -9. Point C is located at the ordered pair 10, -3. Again, X direction left and right, Y direction up and down. And then my last point, point D, is located at the ordered pair 4, -3. When I look at my rule, this is telling me take all of the Y values, which are in the back of the ordered pair, and move them to the front. That's what the Y in the front means. It's also telling me take all the X values, which are in the front, and move them to the back. Also make them the opposite of what they were. I know that we noticed that the Y is positive and the X is negative. That doesn't mean your ordered pair will follow a format of a positive number, negative number. Focus on the fact that this Y means just take the Y as it is and move it to the front. This negative X means take the X, move it to the back, but make it the opposite. So I'll go ahead and make these changes, putting the Y values in the front as they are, and putting the X values in the back, but making them the opposite. These happen to be positive numbers, so they will become negative numbers because negative numbers are the opposite of positive numbers. However, if they were negative numbers, they would become positives. Again, in this situation, the negative in front just means make it the opposite. All right, now that I have all my ordered pairs, I'll go ahead and plot those. So we always start at the origin when plotting points. This is a -9, so I'll go to the left 9 and then down 4. Then we have a -9, 10. Again, start at the origin, go to the left 9 and down to -10. Then I have a -3, 10, and then a -3, 4 for this. Remember, the shapes should look exactly the same, but you are expecting them to have done some type of turn. And then finally, you will be asked in a separate quiz to determine lines of symmetry and rotational symmetry. You can see some examples here on the screen. So I first have example 1, the letter A. This one has one line of symmetry, one line that you can draw in either a vertical, horizontal, or diagonal fashion, that when you fold the shape along that line, all the points line up exactly. They're mirror images of each other. Looking at example number 2, this flower has both line symmetry and rotational symmetry. You can see the line symmetry on the screen. There's 6 lines of symmetry there. I can draw through any of these petals essentially and get exactly the same shape. And I can also draw between the petals and get exactly the same shape when I fold it on itself. When you're looking for rotational symmetry, you're looking to be able to take any point of your shape and rotate it less than a full turn, so less than 360 degrees. If I rotate one petal to the next, does it look exactly the same as it started? If so, then the answer is yes, I have rotational symmetry. Count how many times you are able to rotate that shape in order to get back to the starting point. This one can rotate 6 times. So a normal full rotation would be 360 degrees. I'll take 360, divide it by the 6th number of turns, and I'll get my degree of rotation at 60 degrees. Looking at example number 3, this butterfly is perfectly symmetrical on the left and the right. I can draw a line of symmetry right through the center, and then all of the parts fold over on each other to prove that line symmetry. And then finally, number 4, we're looking at a square. I have 4 lines of symmetry that you can see here on the screen. Each of these are horizontal, vertical, and then we also have diagonal as well. And this also has rotational symmetry. I can take any one of these vertices or corners of the square, rotate it to the other corner, and it would look exactly the same. I can rotate it 4 times around until I get back to the original position. So 360 divided by 4 is a 90-degree angle of rotation. This is everything that you will need to know on your upcoming quizzes covering standards G.2, G.3, and G.4. These cover various topics on transformation, transformation definitions, and the effects of transformations. Now, just completing each of these quizzes can get you up to an 85%, which means that you have met expectations. If you would like to exceed expectations and potentially earn up to a 100% on each of these quizzes, you have options to prove that you can draw, describe, and recognize rigid transformations of all types within a coordinate plane. You can also explain how the transformations affect a figure's position in complex and challenging examples. One way that you can show this is to complete the Exceeds Expectations IXL assignment that I will post in Google Classroom. If you complete that one assignment, it will have questions for all three standards, and you will be able to exceed expectations in all three mastery quizzes. You can also create a video of you completing all three mastery quizzes and explaining every question along the way, explaining your reasoning for choosing each of the answer choices that you did. That will count towards exceeds expectations on each of the mastery quizzes. You can also create a video and use your own slides to explain all of the topics that we will cover on each of these mastery quizzes. So you will need to tell how to identify the type of transformation, how to reflect, translate, and rotate an image on a coordinate plane. You will need to perform that act there. And then also how to identify line and rotational symmetry within an object. If you do this, this will cover all three standards and you will exceed expectations in all three standards. Or you can meet with me during WIN and cover that third option, which would be creating your own slides to show and explain those topics. Again, if you complete any one of these four options, you will be able to exceed expectations on all three quizzes covering these standards G2, G3, and G4. Good luck on your quiz.